Okay, next up we'll talk about the current flowing in a flat coil. So what we have here, we have a coil here, just one circle around here. Okay, what you do is look at the magnetic effect, okay, of the flat coil. What's the magnetic pattern? Think of it as, in this point, there's a current going in. So think of it as this point here, current is going in. At this point over here, what's happening? Current is coming out. So it's represented by a dot. So using your right hand grip rule, okay, you will know that the magnetic pattern looks like this. A magnetic pattern. So when you look at this magnetic pattern here, what do you realize? You realize that in the center, all of the magnetic fields are aligned. At this point here, all of them are facing downwards, which means that it will generate a north pole here and a south pole over here when you got a coil like this. Okay, it will generate a north pole here and a south pole over here. This is what your flat coil does. Okay. And also the other thing to note is that it is stronger along the inside of the coil than the outside. Okay, not much magnetic field here. Okay, it is stronger within here. So the magnetic pattern you can see from it. Okay, now this is for a single flat coil. So what are the ways we can use to increase the magnetic strength? First, we can increase the current. Okay, increase the current. When you increase the current, the strength will increase. The other thing what we can do is increase the number of turns of the coil. In this case, it's only one flat single coil, so not too much of an issue. What if there's more? Then that's where this comes in handy. Okay, this is for more than one coil. Okay, so now when your flat coil, okay, let's say one coil, we make it into many coils. Okay, many coils, many. We call this many coils, we call it a solenoid. So that's why you can see here, when we increase the number of turns of the flat coil, we'll get a solenoid. Okay, solenoid. Now, same thing that we have seen just now, the magnetic field is stronger inside the solenoid than outside. So how do we show it? It is actually by using closer magnetic fields. Okay. The other thing is also, in actual fact, the fields inside the solenoids, they are parallel. The magnetic field lines inside the solenoid, they are parallel. So it shows the strength almost uniform inside the solenoid. Okay. Now, so that's for a solenoid. How can we reverse the magnetic field produced? What we can do is we can reverse the current. So this part has many random things about a solenoid. Okay, please remember to take note of this. First one, we talk about learning how to reverse the magnetic pole. Okay. Next up, we say that the magnetic field strength inside is stronger. Okay, it's almost uniform throughout in the middle. So this is a result. Okay, or I should say part of it. Part together. Okay, part A, part B. And the last one, we talk about increasing the strength. There are actually three ways of increasing the strength of a solenoid. Okay, we talk about increasing the strength. First, we firstly, same as the one before, we increase number of current. Next, we increase the number of coils. So maybe from 10 coils, now we become 20 coils. And the last one, we put a soft iron core in the middle to strengthen. Okay, this is to strengthen the magnetic effect.